Good afternoon. I am Nancy. I want to represent on isomerism. Isomers are the compounds which have same molecular formula but different structural formula, and the phenomena is known as isomerism. Isomerism has two types: structural and stereoisomerism. Structural isomerism, compounds which have different structural formula and same molecular formula, and stereoisomerism, which have same molecular formula and different by atoms in a space. Structural isomerism has 6 types: chain position isomerism, ring chain isomerism, functional isomerism, metamerism, and isomerism. Chain isomerism are the isomerism which have same molecular formula and differ only by nature of carbon chain. Butane has two isomers, butane and methyl propane. Position isomerism which has same molecular formula but differ only by position of same functional group. Ring chain isomerism, compounds which have same molecular formula but differ only by differ only by ring chain isomerism, which have same molecular formula and differ only by and possessed ring and chain like propane and cyclopropane, and meta isomerism, which are differ only by alkyl groups, and protoisomerism, which exist in dynamic equilibrium, like that they are look like same like ethyl, diethyl ether or methyl ether. And stereoisomerism, which it has two types: geometrical and optical. Optical isomerism and geometrical isomerism. Geometrical isomerism, in which plane polarized light and non superimposable. Geometrical which geometrical Thank you.
Good afternoon, everyone. My name is Neha. My roll number is 03. I am from BSc first semester, and I am here for representing my presentation on the topic intermolecular forces. So first of all, intermolecular forces may be attractive in nature or they can be repulsive. They are also known as van der Waals forces.
The आवाज तेज रखना.
It is classified into various types. First is dispersion forces, London dispersion forces. These forces work in the molecules which are dipole. For example, let us take an example of molecule HCl. Here H is carrying partial positive sign and chlorine is carrying partial negative. Similarly, the second molecule of HCl is here. Now here the interaction between chlorine and hydrogen atom, this is termed as London dispersion forces. Second is dipole induced dipole forces. In these type of forces, one molecule is polar in nature. Let's take the same example, HCl carrying partial positive and negative sign respectively, and the other molecule is any kind of which is covalent, like hydrogen molecule. Now in this molecule also there is some covalent, this bond is covalent in nature, but some polar character is also in this bond. So due to present of this dipole, here a partial positive and negative induction of charge occurs, due to which they interact with each other and dipole-induced dipole forces take place. Third type is induced dipole-induced dipole. In these kind of forces, both molecules are non-polar and molecular distortion takes place. Partial positive part of one molecule interacts with the another part of the different molecule having partial negative character. One such kind of forces is hydrogen bonding. This bonding occurs between special compounds having electronegativity difference, large electronegativity difference. For example, hydrogen bonded with most electronegative elements of the periodic table, such as fluorine, oxygen, nitrogen. Now let us take an example of hydrogen fluoride molecules. Here, fluorine molecule of one fluorine atom of one molecule interact with the hydrogen atom of another molecule through hydrogen bonding. These forces are usually stronger than the above dispersion forces. Similarly, in water, H2O, hydrogen bonding takes place. Now, if we take an example of H2O and H2S, bonding in H2O is more stronger than H2S due to hydrogen bonding. If we talk about strength of bond, then ionic bonds are strongest. After that, covalent bonds. After that, dispersion forces. In this, first dipole-dipole, then dipole-induced dipole, and then induced dipole-induced dipole. Hydrogen bonding is more stronger than this dispersion forces.
Good morning, everyone. I am Tanu Sharma from BSc Chemistry Honors first year. Today I am here to represent my topic hybridization. Definition: intermixing of atomic orbitals to form new type of hybrid orbitals is called hybridization. Types of hybridization in carbon atom. There are three types of hybridization in carbon. First one is sp, second sp2, and third is sp3. sp hybridization, intermixing of one s and one p orbital to form same number of hybrid orbitals is called sp hybridization, having linear structure with bond angle of 180 degree. Example is C2H2. Now sp2 hybridization, intermixing of atomic orbitals, one s orbital and two p orbitals to form same number of hybrid orbitals is called sp2 hybridization. Example C2H4 and having trigonal planar structure. Now sp3 hybridization, intermixing of 1s and 3p orbitals is called sp3 hybridization, having tetrahedral structure. Example is CH4. Now other types of hybridization is sp3d, in which one s3p and 1d orbital intermix to give same number of hybrid orbitals is called sp3d hybridization, having structure trigonal bipyramidal. Example PCl5. In PCl5 there are 2 axial bonds and 3 equatorial bonds, which has the sp3d hybridization. Next is sp3d2 hybridization, in which one s orbital, 3p orbital and 2d orbital intermix to form new hybrid orbitals of same number, having octahedral structure. Example is SF6. In SF6 molecule, there is sp3d2 hybridization. Next is sp3d3, in which one s orbital, 3p orbital and 3d orbital intermix to give same number of hybrid orbitals. Example is IF7. In IF7 there is sp3d3 hybridization, having pentagonal bipyramidal geometry. Characteristics of hybridization. Atomic orbitals that gets intermixed having less energy difference, and the new hybrid orbitals form having similar shape and energy, and but a different orientation. Both fully filled and half filled orbitals show hybridization, but having less energy difference. The hybrid orbitals are more stable than other ones. Thank you.
Myself Preeti, and today's my topic of presentation is carbenes. First, we start from its definition. Carbenes are a highly reactive molecular species containing divalent carbon atom. This basically occurs as an intermediate in many organic reactions. Common example of carbenes are methylene, phenyl carbene, etc. Carbenes is basically of two types. One is singlet and second one is triplet. Okay. First we discuss about how carbenes are formed. So there are many carbenes, मतलब basically ये एक प्रोडक्ट नहीं होता, ये रिएक्शन के बीच में फॉर्म होगा और बीच में ही खत्म हो जाएगा. इसका कुछ एग्जांपल ले लेते हैं हम, जैसे CH Cl3. इसमें हम बेस ऐड करेंगे तो यहाँ से रिएक्शन कुछ Cl3 यहाँ से बॉन्ड ब्रेक होगा और यहाँ से हमारा सबसे पहले H2 निकल जाएगा. फिर जो हमारा K पॉजिटिव आयन है उसके साथ ये Cl जो नेगेटिव है एक इसको रिमूव कर लेगा, तो यहाँ से एक हमारा KCl निकल जाएगा और ये बन जाएगा CCl2. तो ये हमारा एक कार्बीन मॉलिक्यूल बन गया है जिसमें 2 इलेक्ट्रॉन और बॉन्डिंग के लिए प्रेजेंट है. और इसके अलावा ये एक डाईअज़ो मीथेन से भी बनाया जा सकता है. इसमें CH2N2 जो कि ये एक बहुत ही फेमस रिएक्शन है क्योंकि इसमें बहुत ज्यादा एनर्जी रिलीज होती है. सो यहाँ से N2 गैस बन के निकल जाएगी और हमारा यहाँ पे C मिथिलीन बच जाएगा यहाँ पे हमारा. इन सब के अलावा अब हम सिंगलेट ट्रिपलेट कार्बन की बात कर लेते हैं. इसमें सिंगलेट कार्बन में कार्बन के पास ऑब्वियसली 6 इलेक्ट्रॉन होते हैं, तो ये एक न्यूट्रल स्पीसीज है, बट ऑक्टेट कंप्लीट नहीं होने की वजह से ये एक इलेक्ट्रॉन डेफिशिएंट स्पीसीज भी होती है कार्बन. तो इसमें ये एक इलेक्ट्रोफाइल की तरह काम करती है. इसकी हाइब्रिडाइजेशन देख लेते हैं हम एक बार. 1s2 2s2 2p2. तो ग्राउंड स्टेट पे इसकी हाइब्रिडाइजेशन sp2 आएगी जिसकी ज्योमेट्री होनी चाहिए थी ट्राइगोनल प्लेनर. बट जब ये इसकी ऑब्जर्वेशन की गई तो ट्राइगोनल प्लेनर ना मिलके एक बेंट शेप में मिला। वो बेसिकली यहीं से आया था। ये 2s2 हो गया और ये यहाँ पे p ऑर्बिटल हो गए 2p2 के। अब इसके हाइब्रिडाइजेशन निकालेंगे हम तो कुछ ऐसे आएगी sp2 sp2 sp2। यहाँ पे एक तो कंप्लीटली पेयर्ड है, बाकी अनपेयर्ड है, तो ये एक हंट्स रूल को भी फॉलो करता है, जिसमें ये बताया जाता है कि जब तक सारी ऑर्बिटल्स में एक एक इलेक्ट्रॉन फिल नहीं हो लेता तब तक पेयरिंग स्टार्ट नहीं होगी। वहीं पे ट्रिपलेट कार्बन में हम कार्बन के एक्साइटेड स्टेट के बारे में बात करेंगे, उसमें हाइब्रिडाइजेशन sp आएगी और हंट्स रूल को ये फॉलो नहीं करता है। सॉरी, ट्रिपलेट कार्बन हंट्स रूल को फॉलो करता है, उसमें हाइब्रिडाइजेशन sp आएगी, वो हम उसकी शेप से देख सकते हैं। इसमें py और pz में एक एक इलेक्ट्रॉन प्रेजेंट होगा। इसकी शेप लीनियर होती है। वहीं पे इसकी शेप कुछ ऐसे आएगी। ये हाइड्रोजन के साथ साइड बॉन्डिंग में है और एक वैकेंट p ऑर्बिटल इसमें होगी। और ये जो दो इलेक्ट्रॉन यहाँ पे पेयरिंग में है वो हम इस साइड हो जाएंगे sp2। सिर्फ मिथिलीन के केस में ही ये सिंगलेट कार्बन ज्यादा ट्रिपलेट कार्बन ज्यादा स्टेबल होता है। एक सेकंड।
Hello everyone, my name is Himani from BSc first year chemistry honors. Today my topic is hybridization. The process of intermixing of atomic orbitals of same atom having same energy in such a way that they redistribute their energy and form new orbitals of same shape and same energy. Condition for hybridization. Hybridization take place during the bond formation. Second, hybridization take place using hybrid orbitals and condition for hybridization. First, the hybridization take place during the bond formation. Hybridization involves vacant orbitals of sp_d subcells in an atom. Hybridization use vacant orbitals of sp_d orbitals. Types of hybridization. First, sp hybridization, in which one s and one p orbital involve and form two new hybrid or sp hybrid orbitals which have identical shape and structure. In this the bond angle is 180 and the shape is linear. Example CO2. Example CO2. Second, sp2, in which one s and two p orbital hybrid intermix and form three hybrid orbitals in which the angle is 120 and the shape is trigonal bipyramidal. Example CO2 carbonate ion CO2 CO3 2 negative and the sp3d orbital in which one s 3p दोबारा से स्टार्ट करो, सारी कंफ्यूजन हो रही है यार, ये तो कंफ्यूज नहीं हो रही मैं ज्यादा।
चलिए एक बार दोबारा से स्टार्ट कर।
Good afternoon, everyone. Myself, Shivani. I representing my views on the topic of stereochemistry. Stereochemistry is a branch of chemistry which deals with the study of arrangement of atom or group of atom in three-dimensional space is called stereochemistry. Now, one of the most important characteristic properties of organic compound is isomers. Isomers, which are the compound which have same molecular formula but different in their structures, are called isomers. There are two types of isomers: structural isomers and functional isomers. Structural isomers are the compound which having same molecular formula but different in their structures are known as structural isomers. And there are 6 types of structural isomers. First is chain isomers. The compound having same molecular formula but different in their carbon chain are known as chain isomers. For examples, butane, for example, butane and isobutane. Their molecular formula is C4H10 and their structure is different. For example, butane is CS3, CS2, CH2, CS3, and the isobutane is CS3, CH, CS3, CH2. So their molecular formula is same, but there is different in structures, are known as chain isomerisms. The next type of structural isomer is position isomer. Position isomer are the compound which having same structure but different in carbon chain or functional group are known as position isomers. For example, but 1-ene and but 2-ene, CH3, CH, CS2, CH double bond, CS3, and CS3, C double bond, CS. It is position isomers. And the next type of structural isomer is functional isomer.
नहीं MSc का proposal दे रखा है.
Functional isomers are the compound which having same molecular formula but different in their function. Functional group are known as functional isomers. For example, C2H6O. So we can write as CH3, CH2, OH, and we can write as CH3. This is ethanol. And this is methoxy methane. The next type of structural isomers is metamerisms. Metamerisms are the compound which having same molecular formula but different number of carbon atom in either side of any functional group. For example, ethoxyethane. Ethoxyethane is a metamer of 1-ethoxy, 1-methoxypropane. The next type of structural isomer is tautomerism. Tautomerisms are the compound which exist in dynamic equilibrium. For example, CH3, C double bond O, OH. This is acetaldehyde. And it exists in dynamic equilibrium with CH2, CH double bond
सिर्फ क्या किया है उसमें डिस्ट्रीब्यूशन किया है
OH. So this type, this type of example is tautomerism, and the last one is ring chain isomerism. Ring chain isomerism, the compound having same molecular formula but different in their but exist in ring or cyclic structures. For example, C3H6. So it can be written as CS3 CH double bond CS2. So this is propene. And in cyclic structure,
इसमें भी हुआ ना, तो उसी में इसलिए तो मैंने सिर्फ एक ही सेट का है आपको,
we can write as
पूरे उस सेट को रिवाइज करके मैं देख के
cyclopropene.
फिर फर्दर मैं डिमांड करूंगा लैब के।
Thank you.
Good afternoon, sir. Good afternoon, everyone. Myself, Tanu. Today's my topic is gas chromatography. Now I represent my presentation on this gas chromatography. Firstly, I give the definition of gas chromatography. The adsorption chromatography involves the simultaneous identification and separation of the compound present in the gaseous mixtures over the saturated gaseous liquid solid phase and unreactive gas mobile phase due to partitioning between the gas phase and solid liquid phase is called the gas chromatography. Here two type of gas chromatography: gas liquid chromatography or gas solid chromatography. Now I represent the gas chromatography with help the diagram. It is carrier gas. It is flow controller. It is injector. It is column. It is detector. It is amplifier. It is chromatogram data saver. Firstly, I describe the type of this diagram. It is carrier gas. Secondly, flow controller. Third is injector. Injector is connected with column. The mobile phase and sample is injected in the injector. Next is column. Column is the heart of gas chromatography, which deals the column is connected with the injector one and to the second and is connected with the detector, or it is detector, or and fifth is amplifier. Now last is chromatogram, whose save the old data saver. Now I explain the process of this gas chromatography. The pure pure mobile gas is entered in the column through the carrier gas. After that inject after that after that the mobile phase gas is through the carrier gas, not neither though fast or neither slow, because the gas is must take time in column for the competition between the mobile phase and gas phase. After that injector is injected the sample compounds in this injector. After that the different components which come out of the column with carrier gas, or which is take the interval of time. After that column is take max. After that, when the different component come out with the column, and then the current is maximum. When only carrier gas is come out column, then the current is zero. But different component emerged with the carrier, then the current is maximum. The different components come out carrier gas with the interval of time and emerged. When different component emerged with carrier gas, then take different rate of time and interval of time. After that the column is reached to detector, and after that the gas is reached to detector, and detector and the I give a signal in the chromatograph, and we put the current is zero. When amplifier is connected with the integrator, then the connected with integrator, and after that the chamber, the amplifier is connected between the chamber and detector, and the liquid gas is surrounded by the chamber, and the compound is change our original state. After that we change the after we found the changes, and we collect change and different and collect the compounds, and the changes are depend on the following factor: type of gas chromatography, length of gas chromatography. Thank you.
वेरी गुड आफ्टरनून सर, माई सेल्फ प्रिया। आज मैं आपके सामने कार्बो एनायंस के बारे में अपनी एक्सप्लेनेशन देना चाहूंगी। कार्बो एनायंस आर व्हाट? बेसिकली कार्बो एनायंस आर एनायंस ऑफ कार्बन, जिसके अंदर कार्बन कैरीज ए नेगेटिव चार्ज, यूजुअली विथ 3 सब्स्टिट्यूएंट्स for a total of 8 valence electrons. कार्बो एनायंस कार्बन के ही एनायंस होते हैं जो फॉर्म किए जाते हैं by the removal of a positively charged atom or a positively charged group of atoms from the carbon atom. कार्बो एनायंस को हम कार्बन एसिड्स के कंजुगेट बेस भी बोलते हैं। कार्बो एनायंस फॉर्मेशन में हमें पॉजिटिवली चार्ज एटम को रिमूव करना होता है, इसलिए कार्बन के ऊपर नेगेटिव चार्ज आ जाता है। कार्बो एनायंस के अगर टाइप्स की बात करें तो कार्बो एनायंस 3 टाइप्स के होते हैं, जिन्हें हम प्राइमरी, सेकेंडरी एंड टर्शरी कार्बोकेटायंस बोलते हैं। इन्हें मतलब 1 डिग्री, 2 डिग्री और 3 डिग्री में भी डिफाइन कर सकते हैं। अगर कार्बो एनायंस की स्ट्रक्चर की बात करें तो इनकी स्ट्रक्चर के अंदर जो कार्बन एटम होता है वो sp3 हाइब्रिडाइज्ड होता है। इनकी स्ट्रक्चर NH3 मॉलिक्यूल की तरह ट्राइगोनल पिरामिडल होती है, जिसके अंदर 3 बॉन्डिंग पेयर ऑफ इलेक्ट्रॉन्स होते हैं और एक नॉन बॉन्डिंग पेयर ऑफ इलेक्ट्रॉन्स होते हैं। क्योंकि NH3 मॉलिक्यूल की तरह इनके अंदर लोन पेयर ऑफ इलेक्ट्रॉन्स प्रेजेंट होता है। इनकी स्ट्रक्चर के अंदर ये कॉन्फ़िगरेशन के अंदर अमोनिया मॉलिक्यूल जो कि न्यूट्रल माना जाता है, न्यूट्रल होता है, उसके साथ मैच करते ही आइडेंटिकल होते हैं। अगर इनकी रिलेटिव स्टेबिलिटी के बारे में हम बात करें तो इनकी स्टेबिलिटी ऑर्डर बेसिकली 3 डिग्री, 2 डिग्री एंड 1 डिग्री, जो कि कार्बोकेटायंस के स्टेबिलिटी ऑर्डर से जस्ट ऑपोजिट होता है। इनकी स्टेबिलिटी को इफेक्ट कर
कार्बन आयन की 1 डिग्री इज ग्रेटर देन 2 डिग्री इज ग्रेटर देन 3 डिग्री होती है।
सर एक बार आप इसको पॉज कर दोगे, मैं कुछ कहना चाहती हूँ आपसे। कार्बो एनायंस की स्टेबिलिटी को हम 2 तरह से इफेक्ट कर सकते हैं। एक तो इंडक्टिव इफेक्ट इन्हें
इसको कट कर दो।
यानी कि प्लस आई इफेक्ट जो होता है उससे स्टेबिलिटी क्या होती है, डिक्रीज हो जाती है। क्योंकि इलेक्ट्रॉन विड्रॉइंग ग्रुप अगर कार्बन के साथ अटैच होगा तो वो इलेक्ट्रॉन रिलीजिंग ग्रुप अगर कार्बन के साथ अटैच होगा तो वो क्या करेगा, वहां उस कार्बन के ऊपर इलेक्ट्रॉन्स को, उस कार्बन को इलेक्ट्रॉन से रिच कर देगा। उस कार्बन की वो कार्बन इलेक्ट्रॉन रिच हो जाएगा, जिसकी वजह से क्या होगी, उसकी स्टेबिलिटी डिक्रीज हो जाएगी। अगर हेलोजन के केसेस में बात करें स्टेबिलिटी की, तो स्टेबिलिटी ऑर्डर फ्लोरीन इज द मोस्ट इलेक्ट्रोनेगेटिव एलिमेंट। सो ये क्या करेगा, ये एक इलेक्ट्रॉन डोनेटिंग विड्रॉइंग ग्रुप है। सो इसी वजह से ये क्या कर देगा, कार्बन एटम की जो स्टेबिलिटी होती है उसको इंक्रीज कर देगा। सो द factors which affect the stability of carbon ions are inductive effect and electronegativity. Stability of carbo anions is directly proportional to electronegativity and inversely proportional to plus I effect. Thank you.
हेलो बेटा, नेक्स्ट स्टार्ट कर दो। स्टार्ट।
Good afternoon, everyone. My name is Monica. My roll number is 030. I'm going to present about the topic carbene and nitrene. Carbene are neutral divalent carbon species in which carbon is bonded to a monovalent atom, and 2 non-bonding orbitals contain electron between them. They are also called methylenes. They act as Lewis acid and electrophiles.
They are short-lived and highly reactive chemical species. Now, generation of carbenes. First, by photolysis or thermal decomposition of cyclopropene and oxirane. By HV or light. So it gives carbene C6H5 CH2CH2, oxirane CH6H5 C6H5C for H. On thermolysis or decomposition, it also gives carbene C6H5 CH double bond O C6H5CH. So second, by thermolysis or decomposition of ketene and diazoalkanes. So let's take an example of diazomethane. So it gives N triple bond N plus CH2. By diazoketenes, so it gives CH2CO. By the action of a strong base like potassium tertbutoxide on chloroform. So C CH3. So it gives CCCL. It is unstable, so we can write it as chlorine CCl2. Now, depending upon the distribution of non-bonding electrons in an orbital, we have classified carbenes into two types, singlet carbene and triplet carbene. Singlet carbene, in which the two non-bonding electrons are present in one orbital. They have no unpaired electrons. They are represented by this. And they have no dipole moment. So they cannot be detected by electron spin resonance. Now, second is triplet carbene. Triplet carbene, in which the non-bonding electrons, they are present in different orbitals of equal energy with spin parallel according to Hund's rule of maximum multiplicity. They have unpaired electron, so they have permanent dipole moment. Say they can be detected by electron spin resonance. Now, what is the structure of carbene? Singlet carbene structure. In which the two carbon is sp2 hybridized, and the sp2 hybridized orbital forms sigma bond with the two monovalent atom. P orbital is empty. The structure is similar to that of carbocation. Now, triplet carbene. The carbon is sp hybridized, and the two sp orbitals form two sigma bonds with the two monovalent atom, and the non-bonding electrons are present in the unhybridized p orbital, py and pz. It has a linear species and it behaves like biradical or diradical. Stability, triplet carbene is more stable comparison to singlet carbene. Because of the inter-electronic repulsion, it led to the increase in the energy. Now let's talk about nitranes. So nitranes are short-lived high chemical reactor species. It has sectet of electrons, so it has a strong tendency to gain electrons. Now let's talk about the generation of, it also acts as Lewis acid or electrophiles. Generation. First, by photolysis or chemical thermolysis, decomposition of azides and isocyanates. So it gives N triple bond N. Now our N double bond C double bond. Now by the acid catalyzed of sulfonation from orthohydroxyl azides orthosulfonates. So it gives water as a side product ArSO3 and nitrines. Now, they are also classified into two types, singlet or triplet nitrene. Singlet nitrenes in which the non-bonding electrons are present as pairs. Triplet in which there is one pair of electrons and two unshared electrons. Structure of singlet carbene is
Nitrene beta carbene.
nitrene, in which nitrogen is sp2 hybridized and one sp hybridized orbital form one sigma bond with monovalent atom and the other two sp2 hybrid orbital containing the two non-bonding electron as pair. Now talk about the triplet carbene, in which one sp orbital forms one sigma bond with monovalent atom and the hybrid orbital contain single electron each and one sp orbital contain one non-bonding electron pair. Now stability of nitrogens. Nitrogen is too reactive to be isolated under ordinary conditions. Alkyl nitrogens, they are trapped in lattice at 4 Kelvin, and aryl nitrogens, they are trapped at 77 Kelvin. Now, nitrene is trapped in the lattice, for example, C6H5, in the presence of carbon monoxide. So it gives C6H5N, or to give isocyanate to C6H5NCO. Thank you.
Next one. Slowly out. Start with.
Good afternoon, everyone. Myself written in front of you to give the presentation on the topic bond fission and reaction intermediate. First of all, what is the bond fission? The process of breaking of bond is called bond fission, and generally it is of two types: homolytic bond fission and heterolytic bond fission. Homolytic bond fission. It is the process in which each of the atom takes away their own electron is called the homolytic bond fission, and homolytic bond fission generally take place in the presence of light, and homolytic bond fission take place when both the atoms are of same electronegativity. During homolytic bond fission, triplet carbon free radicals are generated, and during this less energy is consumed, and it is generally denoted by curved half arrow. Next is heterolytic bond fission. It is the process when each of one atom take away both the electron is called heterolytic bond fission, and it generally take place in the presence of heating, and it take place when both the electron are of different electronegativity. During the heterolytic bond fission, cation, anion, singlet carbene are formed, and it take place. It required more energy, which is obtained due to ion-ion interaction. Next are reaction intermediate. Reaction intermediate are the short-lived reactive species which are formed during the reaction by the homolytic or heterolytic bond fission. For example, carbocation, carboanion, free radical, nitrene, benzene, etc. Carbocation are the positively charged short-lived reactive species which are formed by the heterolytic bond fission, and carbocation are generally of three types: primary carbocation, secondary carbocation, and tertiary carbocation. Next is carbanion. Carbanion are the negatively charged short-lived reactive species which are formed by the heterolytic bond fission. They are also further three types: primary, secondary, and tertiary carbanion. Free radicals are the neutral trivalent short-lived reactive species which are formed by the homolytic bond fission, and they are also further three types: primary, secondary, and tertiary. Next are carbene are the neutral divalent reactive species which are formed during the reaction by homolytic or heterolytic bond fission, and carbene are of two types: singlet carbene or triplet carbene, which are formed on the basis of heterolytic cleavage or the homolytic cleavage. Nitrines are the neutral monovalent reactive species which are formed during the homolytic or the heterolytic bond fission are called nitrine, and nitrine are also further two types: singlet nitrine and the triplet nitrine. Next are benzene. Benzene are the neutral aromatic short-lived reactive species having a carbon-carbon triple bond are called the benzene. Thank you.
Good afternoon all, myself Tanisha and I'm going to discuss about thin layer chromatography. So thin layer chromatography is a technique used to isolate non-volatile compounds. The technique is used on the thin sheets of aluminum foil or glass, which is coated with an absorbent material usually used as aluminum oxide or silica gel. So every spot has a retention factor, which is expressed as retention factor is equal to the distance traveled by the sample upon distance traveled by the solvent. So if we discuss about the principle, then thin layer chromatography depends on the separation principle. Separation relies on the affinity of compounds towards both the phases. The mobile phase compounds move over the surface of the stationary phase. So the movement is occurred in such a way that the particles or the compounds having high affinity move slowly and other compounds move faster. As a result, the separation is attained. On completing the separation, the spots are uh, found at different levels and the spots also increase and the solvent also rises. Here the solvent is non-polar as the silica gel used is the polar substance. So there are many advantages of thin layer chromatography. Let's discuss some of them. So the first and the very basic is it is used in the detection of compounds present in the mixture. Second, it is also useful for the purity of compounds. Third, it is also used for for monitoring the progress of reaction. Next, thin layer chromatography is also beneficial in the forensics, it is useful for the decomposition of fibers. And thin layer chromatography is also beneficial in the medicinal plant and the detection of their components. So if we talk about the limitations, then it has only few limitations. The one is, and very basic is, it is only possible in single mobile phase. And the second limitation is thin layer chromatography can be done of the compounds or the mixtures only up to 100 megagram. Thank you.
Good afternoon. My name is Komal from BSc First Year Chemistry Honors. My presentation on the topic on the topic of preparation of alkane. Firstly, we know about what is alkane. Alkane, the compounds which have only single carbon bond. And alkene also called paraffin. Paraffin means they have low reactivity due to absence of reactive site. Reactive site means double bond, triple bond, and functional group. And alkanes have a general formula CnH2n plus Me2. Alkanes used for fuels. This alkanes in LPG gas found propanes and butanes. Now now focus on the how can prepare alkanes by the step-by-step methods. Firstly, we know lower and higher alkane to increase in कार्बन एटम इन चेन के अंदर हम इंक्रीज कैसे करते हैं, जैसे बाय द हेल्प ऑफ वुर्जी रिएक्शन. हमें दे रखा है इथेन, इथेन से बनाना है जैसे ब्यूटेन. तो फर्स्ट इथेन है, इसको फर्स्टली तो इनिशिएट करेंगे HbCl की प्रेजेंस के अंदर. फिर हमें एल्काइल हैलाइड की फॉर्मेशन होगी. आगे जो वुर्ज रिएक्शन होती है उसका जो रिएजेंट होता है सोडियम ड्राई ईथर की प्रेजेंस मिलेंगे, जिससे हमें ब्यूटेन की फॉर्मेशन होती है. जो वुर्ज रिएक्शन होती है उसके द्वारा हम सिमेट्रिक एल्केन की फॉर्मेशन कर सकते हैं. तो हमें अगर और नंबर ऑफ पे एल्केन की फॉर्मेशन करनी हो तो वो वुर्ज रिएक्शन से नहीं हो सकती. तो टू अवॉइड दिस प्रॉब्लम बाय द हेल्प ऑफ ए कोरी-हाउसी सिंथेसिस रिएक्शन. कोरिहाउसिस रिएक्शन की हेल्प से हम अनसिमेट्रिक कार्बन एल्कीन की फॉर्मेशन कर सकते हैं, जैसे कि यहाँ पे इथेन ले लिया, इथेन से हमें कन्वर्ट कोई भी जैसे प्रोपेन करना है, तो फर्स्टली तो इनिशिएट करेंगे इसे, जिसे हमें हेलोजिनेशन कहते हैं। फिर इसकी जो कोरिहाउसिस रिएक्शन उसका रिएजेंट होता है R2, जिसे हम यहाँ पे CH3 लेंगे, फिर होता है CuLi,
CH3 का ट्वाइस करते हैं,
इसका
CH3 का ट्वाइस।
इसे प्रोपेन की फॉर्मेशन होगी। नौ अगर हमें फॉर्मेशन करी हो डिक्रीमेंट ऑफ कार्बन एटम में, कार्बन चेन के अंदर अगर डिक्रीज करना हो एल्किन की फॉर्मेशन करने के लिए, तो वो कहते हैं स्टेप बाय स्टेप मेथड से। जैसे फर्स्टली है कि इथेन से मीथेन की फॉर्मेशन करनी हो तो वो कैसे करेंगे। फिर इसको KOH एक्वस KOH की प्रेजेंस में करते हैं, जिससे ये जिससे जिससे हमें ये जो प्रोडक्ट मिलेगा वो मिलेगा एल्कोहल। अगेन इसको स्ट्रॉन्ग ऑक्सीडाइजिंग रिएजेंट की फॉर्मेशन करते हैं, जिससे हमें एसिड की फॉर्मेशन होगी K2Cr2O7, जिससे होता है स्ट्रॉन्ग ऑक्सीडाइजिंग रिएजेंट। जो कंप्लीट तो ऑक्सीडेशन करवाता है, जिससे रिमूव करता है कंप्लीट हाइड्रोजन और एडिशन करता है ऑक्सीजन का। अगेन NaOH के साथ रिएक्ट करवाएंगे, इससे जो नेगेटिव पोर्शन है जो Na के साथ रिएक्ट होगा, और जो OH हाइड्रोजन और OH है वो H42 के साथ होगा। अगेन NaOH के साथ रिएक्ट कराने के बाद में जो कंप्लीट है ये आउट हो जाएगा, और जो फॉर्मेशन है वो होगी मीथेन की। तो बाय स्टेप मेथड हम इथेन टू मीथेन की फॉर्मेशन कर सकते हैं। अगर हमें ना इंक्रीज करना हो एल्केन में, ना डिक्रीज करना हो, जैसे कोई भी अल्कोहल दे दिया हो, तो फिर इसको एल्केन में ही डायरेक्ट कन्वर्ट करना हो इथेन के अंदर ही, कार्बन के जो नंबर है उनमें कोई भी चेंज नहीं आया, तो बाय द हेल्प ऑफ रेड फॉस्फोरस या फिर HI इन एक्सेस के अंदर, जिससे इजली हम मीथेन की फॉर्मेशन कर सकते हैं। फिर होता है जैसे कि इथीन दे रखा हो, इसको कन्वर्ट करना हो तो ZnCl है उसकी हेल्प से कर सकते हैं, या फिर प्लेटिनियम या फिर पेरिलियम के साथ जो इथेन की फॉर्मेशन में रहते हैं।
नेक्स्ट आ जाओ।
Hello friends, good afternoon. Good afternoon to all. I am here to give the presentation on the topic of chromatography. The word chromatography is originated from the Greek, from two Greek words. Word chromo means color and graphene means to write. Graphene means to write. It was first employed by the Russian scientist named Mikhail West. It was first used in the separation of colored substance in plants. The process of separation of the colored compounds due to their different moment in the presence of stationary through stationary phase in the presence of mobile phase is known as chromatography. The word stationary phase means in which the solvent molecules moving in the stationary phase is known as the mobile phase, and the stationary phase in which the substance remains rest and in which mobile phases particles are moving. Principle of the chromatography, the principle of the chromatography, it is based on the principle, it is distribution in the two or more phases under the conditions applied. The first phase is the two-dimensional phases, that is stationary phase, that is nothing but a surface, and the other one is the mobile phase. And the mobile phase is based on the condition, is applied on the condition that it is applied in the current counter manner, that is the function of each is opposite to each other. Factors affecting the chromatography. There are so many factors which affect the chromatography, that is there are so many factors which affects the chromatography. First of all, purity of a molecule. Purity of a molecule is depend on that the molecule is depend on is the higher the purity of the molecule, so the adsorbent is high, and the more polar phases is required to remove that adsorption forces. The more polar sources such as alcohols, carboxylic acid, and all, and the other one is adsorbent. Adsorbent is also the one of the most factor that affect the chromatography technique. In the activity of the adsorbent, increases. The activity of the adsorbent decreases when the activity of the adsorbent is not removed, is decreases when the because the water molecule is not be possible to remove from the surface. Classification of the chromatography, there are so many types. First of all, we can classify it on the basis of the phases and different adsorption type. First of all, adsorption chromatography. Adsorption means to stick, it means to stick on the surface. The term is used here to be said that the gas or the other substance which is stick on the surface. Examples, column chromatography and thin layer chromatography, and the other one is partial chromatography. There is the partition of the molecules in between the mobile phase and the stationary phase, that is gas chromatography and GLC. And the other classification is on the basis of the mobile phase is moved in the upward or the downward direction. First is ascending chromatography, in which the mobile phase is going in upward direction to determine the upward direction in the separation of the colored molecules. Examples, thin layer chromatography, paper chromatography. Other one is the descending order, in which the mobile phase is going in the downward direction, that is column chromatography and thin layer chromatography. Thank you.
Next.
Good afternoon, everyone. My name is Renu. I am here to present my topic of isomerism. Before isomerism, let's discuss about isomers. What are isomers? Isomers are the compounds which have same molecular formula but differs in their physical or chemical properties. And this property is known as isomerism. There are different types of isomerisms on the basis of their different internal structures. The two types of isomerisms are structural isomerism and stereoisomerism. Structural isomerisms are the isomers which have same molecular formula, but they differs in their structural formula because of the different arrangement of the atoms in the compounds. Then The stereoisomerism have same molecular formula and same structural formula, but they differ in the arrangement of the atoms or group of atoms around the central carbon atom in the space. The structural isomerism has different types. The types are chain isomerism, ring chain isomerism, position isomerism, functional isomerism, metamerism. Chain isomerisms are isomerisms in which there is a change in the arrangement of carbon atom chain. For example, ethane, there is ethane, propanol, and propane to ol. Then the second one is ring chain isomerism. Ring chain isomerism are the isomerisms which have same molecular formula, but they differ in the open chain and cyclic structures. For example, cyclopropane and propene. The next is functional isomerism. Functional isomerisms have same molecular formula as the above, but it differs in the functional group. For example, ethanol and dimethyl ether. Next one is metamerism. Metamerism is also the part of a structural isomerism in which the compounds differ in the number of carbons either on either side of the functional group. For example, dimethyl ether and methyl propyl ether. The next one is I think that's all for structural isomerism. The next one is stereoisomerism. Isomerism are also two different types: conformational isomerism and configurational isomerism. Conformational isomerisms. These are the compounds which have same structural formula and molecular formula, but they are not superimposable on each other, and they are easily interconvertible into each other because of the rotation of the carbon-carbon single bond. These can be denoted by the three projections, that is Fischer projection, Newman's projection, and Sohor's projection. The conformational isomerisms can be are infinite because of the free rotation of the single bond between the two carbons. Then next is configurational isomerism. Configurational isomerism are the isomerisms in which the molecular formula is same, but they are non-superimposable, and they are not that easily interconvertible into each other except breaking of bond. For example, cis-butene and trans-butene. They are of configurational isomerisms are of two types: optical isomerism and geometrical isomerisms. Optical isomerisms are the compounds whose molecular formula is same, but they differ when they go through the PPL. The one compound which goes through the PPL and tilts left, then its next isomer must be tilted towards the right. The next is geometrical isomerism. Geometrical isomerism is which have same molecular formula but differs in the arrangement of the atoms around the double carbon bond and double carbon bond between the carbons. There are two types of geometrical isomerisms, that are cis and trans. Thank you.
Hello everyone, my name is Payal and my today's topic of presentation is isomerism. Let's talk about this. Isomerism. First we will discuss about its definition. तो हम स्टार्ट करते हैं. आइसोमर्स और आइसोमेरिज्म दोनों की बात करेंगे. तो फर्स्ट आइसोमर्स क्या होते हैं? The compounds which have same molecular formula but different in their physical and chemical properties, and the process by which it occurs is known as isomerism. Now these are divided into two parts. First one is stereo isomer and second one is structural isomer. First, we will discuss about structural isomers. The compound which have same molecular formula but different in their structure are known as structural formulas, and this is now divided into subparts. First one is chain isomer. Second one is position isomer. Third one is functional isomer. And fourth one is metamerism. Now first, chain isomers. The compound which has same molecular formula but different arrangement of carbon atom in chain. Example, N-butane and isobutane. Second one is position isomer. The compound which has the same molecular formula but they have different in their position of multiple bonds and functional groups. An example is ethane 1-ol and ethane 2-ol.
प्रोपेन 1-ol and propane 2-ol. इसमें तो एक ही जैसी बात है.
Okay, sir.
वाला कट कर.
Now third one is functional isomer. The compound which have the same molecular formula but different in their functional groups. For example, ethanol and dimethyl ether. Fourth one is metamerism. The compound which have same molecular formula but different in the arrangement of carbons and group of carbon atom around the carbon chain. Around the function. Now we have discussed about the structural isomer. Second one is stereoisomer. The compound which have same molecular formula and also same molecular formula and structural formula, but they are different around the arrangement of central carbon atom. Now these are divided into two subparts. First one is conformational and second one is configurational. First one is conformational. These are the compound which have same molecular formula and also same structural formula, but and they are also known super impossible images and can be converted into other form by rotating around the carbon single bond carbon. And examples are, let's say this is a horse projection. And if we want to rotate this, we can rotate by 120 degree, and this would be like this.
रोटेशन बेटा हमेशा बस 60 डिग्री में करते हैं बार।
ओके Now, configurational isomers. These are like conformational isomers, but there is one difference between these of two, and the difference is that these cannot be converted into any form other because. And if we want to convert this in another form, we have to break this single bond only. Now there are two types of configurational isomers. These are first one is geometrical and second one is stereoisomers. These stereoisomers have same molecular formula, structural formula, but they are different. They show different behavior towards PPL, that is plane polarized light. And the second one optical, sorry. Now second one is geometrical isomers, the compound which have same molecular formula and structural formula, but they are different around carbon single bond, carbon double bond, carbon atom, and they are, and examples are cis and trans. Thank you.
Good morning. Today's my topic of Good morning. I am Divya. Today's my topic of presentation is isomers. Now we are discuss about the isomers. Isomers have the same molecular formula, but they have different physical and chemical formula. Isomers are two types: structural isomerism and stereoisomerism. Structural isomerism, the isomers which have same molecular formula, but they have different structures, that is known as structural isomers. Structural isomers are of 6 types: chain isomers, position isomers, metamers, chain isomers, metamers, position isomers, tautomers, and ring chain isomers. Now we are discussing about the chain isomers. In this, the arrangement of a carbon atom is different, and in the position isomer, the position of the carbon atom is different, and in the functional isomers, the arrangement of the functional group is different, and in metamers, the number of carbon atom around the functional group is different, and in tautomerism, the molecular formula is the same, but their बट एक पॉइंट ऑफ मीटिंग होता है जो उसके अंदर, उसकी वजह से उनका जो स्ट्रक्चर होता है वो डिफरेंट होता है. नाउ वी विल डिस्कस अबाउट द स्टीरियोआइसोमेरिज्म. स्टीरियोआइसोमेरिज्म व्हिच हैव द सेम स्ट्रक्चर formula and molecular formula, but they have a different स्टीरियोआइसोमेरिज्म में जो स्ट्रक्चरल फॉर्मूला और मॉलिक्यूलर फॉर्मूला होता है वो सेम होता है. Stereoisomerism are of 2 types: configurational and conformational. Conformational isomers which have the same structural formula and molecular formula, but which have same molecular formula and chemical, which have same molecular formula and structure formula, but they can interconvert it into each other by the rotation. In configurational isomers, they have same chemical, same molecular formula and structural formula, but they are not interconverted into each other, like cis and trans butene. Thank you.
माय नेम इज हर्ष, माय टॉपिक कोवेलेंट बॉन्ड। तो सबसे पहले मैं कोवेलेंट बॉन्ड की डेफिनेशन बताना चाहूंगा। कोवेलेंट बॉन्ड फॉर्म्ड बाय म्यूचुअल शेयरिंग ऑफ इलेक्ट्रॉन्स। जो एटम ए है, इसमें जैसे कि एटम ए है और एटम बी है, तो उसके अंदर जैसे कि ये एटम ए है और ये एटम बी है, तो इसमें ये इलेक्ट्रॉन एटम ए का भी है और एटम बी का भी है, और ये इलेक्ट्रॉन एटम बी का भी है और एटम ए का भी है। तो इसमें जो सिंगल कोवलेंट बॉन्ड होता है एक तो, और एक डबल कोवलेंट बॉन्ड होता है, एक ट्रिपल कोवलेंट बॉन्ड होता है। इसमें पोलर और नॉन पोलर होता है। जैसे कि पोलर पोलर में होता है जो डाइपोल मोमेंट है वो होता है, और इलेक्ट्रोनेगेटिविटी डिफरेंस भी होता है। और नॉन इसके एग्जांपल हैं जैसे कि NH3, SO2, HI, HF। और जो नॉन पोलर है उसमें डाइपोल मोमेंट नहीं होता और इलेक्ट्रोनेगेटिविटी डिफरेंस भी नहीं होता। इसके एग्जांपल ब्रोमीन, क्लोरीन, फ्लोरीन एक्सेट्रा। और जो इसकी प्रॉपर्टीज हैं, जो कोवेलेंट बॉन्ड हैं वो सॉफ्ट एंड वैक्सी होते हैं, और इनका मेल्टिंग और बॉइलिंग पॉइंट लो होता है। और ये जो कोवेलेंट बॉन्ड हैं ये रिजिड एवं डायरेक्शनल होते हैं, इसलिए ये आइसोमेरिज्म शो करते हैं। और जो कोवेलेंट बॉन्ड है वो नॉन पोलर कंपाउंड में सोल्यूबल होते हैं। और इसमें जो कोवेलेंट बॉन्ड है इसकी कोवेलेंसी होती है, जो कोवेलेंट बॉन्ड की कोवेलेंसी होती है टोटल नंबर ऑफ इलेक्ट्रॉन्स फॉर्म्ड बाय एटम इन अ मॉलिक्यूल। इसमें जैसे कि ये ए एटम है और ये बी एटम है, तो इसमें जो ये तीन तीन इलेक्ट्रॉन्स हैं, तो इसमें इसकी कोवेलेंसी 3 होगी। ऐसे ही इसमें इसकी कोवेलेंसी 2 होगी और इसमें 1 होगी। थैंक यू वेरी मच।
आ जाओ बेटा, नेक्स्ट आओ, जल्दी आओ बेटा नेक्स्ट।
So today my topic is the van der Waals forces of attraction. Van der Waals forces of attraction given by the Dutch chemist, that is van der Waals. van der Waals ने ये force of attraction दी थी, तो इसलिए इनका नाम van der Waals force of attraction है। नॉन पोलर मॉलिक्यूल्स जैसे कि क्लोरीन मॉलिक्यूल हो गया या ब्रोमीन मॉलिक्यूल हो गया, ये मॉलिक्यूल्स इनको हम डायरेक्ट सॉलिड में चेंज नहीं कर सकते, हमें सबसे पहले इन्हें लिक्विड में चेंज करना पड़ेगा, उसके बाद इन्हें हम सॉलिड में चेंज कर सकते हैं। तो इसका मतलब इनके अंदर कोई ना कोई फोर्स ऑफ अट्रैक्शन प्रेजेंट होनी चाहिए। तो वो जो फोर्स ऑफ अट्रैक्शन है उनको हम नाम देंगे van der Waals फोर्स ऑफ अट्रैक्शन। अगर मैं एक न्यूट्रल मॉलिक्यूल जैसे कि क्लोरीन की बात करूं, तो इन न्यूट्रल कंडीशन इसका जो सेंटर ऑफ पॉजिटिव चार्ज है और इसका जो सेंटर ऑफ नेगेटिव चार्ज डेंसिटी है वो आपस में क्या करते हैं, कोइंसाइड। तो ये आपस में कोइंसाइड करते हैं इन द न्यूट्रल कंडीशन, जिसकी वजह से इसका डाइपोल मोमेंट क्या होता है, 0, और जो ओवरऑल मॉलिक्यूल होता है वो नॉन पोलर होता है। लेकिन कुछ कंडीशंस में जब मॉलिक्यूल्स आपस में कोलाइड करते हैं, तो जैसे ये क्लोरीन मॉलिक्यूल था, ये कंडीशन इसकी न्यूट्रल कंडीशन थी, लेकिन जब दूसरे मॉलिक्यूल ने इसके पास आकर इसको कोलाइड किया, तो इसकी वजह से इसका जो सेंटर ऑफ पॉजिटिव चार्ज डेंसिटी है और नेगेटिव चार्ज डेंसिटी है वो क्या हो गया, डिस्प्लेस हो गई। तो एक एंड इसका पॉजिटिव हो गया और दूसरा एंड इसका नेगेटिव हो गया, और इनके बीच में एक तरह से हम देखा जाए तो एक इंस्टेंटेनियस डाइपोल मतलब जो है वो डेवलप हो गया। इंस्टेंटेनियस मींस कुछ टाइम के लिए डाइपोल हुआ है, यानी मॉलिक्यूल के अंदर परमानेंट डाइपोल नहीं है। ये तभी हुआ है जब इसके अंदर कोलिजन हुई है, यानी कि कोलिजन या कुछ अदर फैक्टर्स के कारण इनके अंदर जो डाइपोल होता है उस डाइपोल का नाम हमने इंस्टेंटेनियस डाइपोल दिया है। इसके जो विक्सिनिटी में इसका जो मॉलिक्यूल है, जो इसके पास है मॉलिक्यूल, इसको देख के उसके अंदर भी 2 एंड्स डेवलप हो जाएंगे, एक पॉजिटिव एंड और एक नेगेटिव एंड। तो इसीलिए इन पॉजिटिव और नेगेटिव एंड्स के बीच में जो फोर्स ऑफ अट्रैक्शन होगी बिटवीन द 2 क्लोरीन मॉलिक्यूल्स जो कि नॉन पोलर हैं, इस फोर्स ऑफ अट्रैक्शन का हमने नाम दिया van der Waals फोर्स ऑफ अट्रैक्शन या लंदन डिस्पर्शन फोर्स, लंदन फोर्स या डिस्पर्शन फोर्सेस। तो ये बात थी इन द नॉन पोलर मॉलिक्यूल्स। पोलर मॉलिक्यूल्स के अंदर इन्हीं जो क्या नाम है जो फोर्स ऑफ अट्रैक्शन है, इनके दो टाइप्स होते हैं. फर्स्ट टाइप इज डाइपोल डाइपोल इंटरेक्शन एंड द सेकंड टाइप इज डाइपोल इंड्यूस्ड डाइपोल इंटरेक्शन. डाइपोल डाइपोल इंटरेक्शन जैसे कि HCl मॉलिक्यूल है, HCl एक परमानेंट डाइपोल है, इसके अंदर एक इसका एंड पॉजिटिव है, दूसरा एंड इसका नेगेटिव है. तो इनके अंदर जो डाइपोल होगा वो परमानेंट होगा, यानी कि अगर मैं इस मॉलिक्यूल को इस तरह से शो करूं तो ये इसका पॉजिटिव एंड होगा, ये नेगेटिव एंड होगा. इसके साथ में ही HCl मॉलिक्यूल जो अलग जो नेक्स्ट क्लोरीन मॉलिक्यूल HCl मॉलिक्यूल होगा, उसके अंदर जो इसका पॉजिटिव एंड होगा और जो नेगेटिव एंड होगा, उनके बीच में जो फोर्स ऑफ अट्रैक्शन होगी, इसका नाम है डाइपोल डाइपोल इंटरेक्शन. इसका जो मैग्नीट्यूड है वो डिपेंड करेगा कि जो HCl मॉलिक्यूल है उसका डाइपोल मोमेंट कितना है. मैग्नीट्यूड किस पे डिपेंड करेगा, इसके डाइपोल मोमेंट पे. और ये जो फोर्स ऑफ अट्रैक्शन है डाइपोल इंड्यूस्ड डाइपोल, इसके लिए हमें एक HCl मॉलिक्यूल एग्जांपल ले सकते हैं, HCl मॉलिक्यूल और साथ में क्लोरीन मॉलिक्यूल या कोई अलग इसके अलावा जो मॉलिक्यूल है. एक तो इसमें परमानेंट होनी चाहिए डाइपोल, यानी कि एक तो होना चाहिए परमानेंट डाइपोल और एक होना चाहिए कोई नॉन पोलर कंपाउंड. जो नॉन पोलर कंपाउंड है वो इसकी विसिनिटी में अगर कोई पोलर कंपाउंड होगा तो इसके अंदर दो एंड्स डेवलप हो जाएंगे, अगेन जैसे ऐसे था, लेकिन यहाँ पे ये पोलर मॉलिक्यूल की प्रेजेंस होना जरूरी है, जिससे अब नॉन पोलर कंपाउंड में भी दो एंड्स डेवलप होगी. इन दो एंड्स के बीच में जो अब ये फोर्स ऑफ अट्रैक्शन होगी दो मॉलिक्यूल के बीच में, इसका नाम होगा डाइपोल इंड्यूस्ड डाइपोल, जिसका स्ट्रेंथ डिपेंड करेगा परमानेंट डाइपोल का जो डाइपोल मोमेंट है वो कितना है, और पोलराइजेबिलिटी ऑफ द नॉन पोलर मॉलिक्यूल, मतलब कि इसकी डाइपोल बनने की क्षमता पे डिपेंड करेगा कि इस पे कितना, मतलब ये पोलराइज हो रहा है मॉलिक्यूल, कितनी इसमें जो ये पॉजिटिव और नेगेटिव है ये बन रहे हैं. जितना ये बन रहे हैं इसका मतलब उनके अंदर फोर्स ऑफ अट्रैक्शन भी उतनी ज्यादा हो रही है, और इसलिए इनका जो बॉइलिंग पॉइंट है वो भी ज्यादा हो रहा है. तो इसका एक एग्जांपल है कि सॉल्युबिलिटी ऑफ नोबल गैसेस इन वाटर लाइक परमानेंट डाइपोल. जैसे कि वाटर है, वाटर एक परमानेंट डाइपोल है, तो इसकी वजह से इनकी सॉल्युबिलिटी डाउन द ग्रुप इंक्रीज होती है क्योंकि साइज इंक्रीज होता है. थैंक यू.
आगे बेटा नेक्स्ट.
Start, sir.
Start.
My name is Ravinder. So my topic is conformational isomerism. The isomerism in which two or more compounds having similar formula and molecular formula, but they do not superimposable on each other and interconverted into in each other by simply rotation by carbon-carbon single bonds. The conformational isomerism is of two types: staggered conformational isomer and eclipsed conformational isomerism. In staggered isomerism, the hydrogen atoms present on the adjacent carbon atoms are maximum apart from each other, so they have less steric hindrance. That's why they are more stable. But in eclipsed conformational isomerism, the hydrogen atoms present on adjacent carbon atoms are present on less distance, so they have high steric hindrance, so they are less stable. And in staggered conformational isomerism, there are two types: anti and Cauchy. In anti conformational isomerism and anti-conformational isomerism, the bulky methyl groups are separated by dihedral angle 180 degree. And but in Cauchy, the bulky methyl group are separated by a dihedral angle 60 degree. So that's why in anti and Cauchy, anti are more stable than Cauchy. And in eclipsed conformational isomerism, it is of two types: fully eclipsed as conformational isomerism and partially. In fully, the bulky methyl groups are separated by 0 degree dihedral angle, but in partially the bulky methyl groups are separated by dihedral angle 120 degrees. So in fully and partially are more stable than fully eclipsed conformational isomerism. Thank you.
Next.
सर स्टार्ट करते हैं सर. My name is Rui from BSc Chemistry first year. Today our topic is hybridization. Do we know that VBT theory about? It says that covalent bond is prepared by formed by partially intermixing of partially intermixing of electrons. For example, this is divalent carbon and this is tetravalent carbon. We know that we react with hydrogen 1 so different the S is reactive with this S and P is reacted with this. So different length happens, but in really the length is same of CH4. So we need the concept of hybridization that there is all have bond are same in this. Then hybridization is it is a intermixing of the orbitals of the same atom of slightly difference in their energies, and this intermixing formed the a different energy level, which we know different energy levels at orbital that we called hybridized orbital. So there is condition of hybridized orbital that only the valence shell orbitals can undergoes hybridization, and hybridization is occurred in only her inner orbitals, and some features are that the bond formed by the hybridized orbital is more stronger than atomic orbitals, and this form a lobes. This is S, this is P. This represents the lobes of hybridization. There are many types of hybridization like SP, SP2 and SP3. And this hybridization shows the geometry of the orbitals, not the shape. Though SP2, SP show our linear geometry and SP2 triangular, planar, and SP3 is tetrahedral geometry. So this is the hybridization. Thank you.
My name is Meng. I'm student of BSc Chemistry first year. Today's my topic is benzene. Benzene is a simple compound of aromatic hydrocarbons. It is made by the combination of hydrogen and carbons. In 1876, Kelvin gave the resonating structure of the benzene. What is the resonance? The first question is what is the resonance? Resonance क्या है? किसी रेजोनेंस का मतलब है कि किसी भी एक मॉलिक्यूल किसी भी कंपाउंड का एक से अधिक स्ट्रक्चर हो और बट उसका जो मॉलिक्यूल फॉर्मूला है वो सेम रहे, उसे हम रेजोनेंस कहते हैं। बेंजीन है, बेंजीन के हमारे पास दो प्रकार के स्ट्रक्चर होते हैं, इसमें मतलब जो बॉन्ड होते हैं बेंजीन के ये डिफर करते हैं। लेट वी सी देयर द फर्स्ट स्ट्रक्चर ऑफ बेंजीन, the bond are there and this is the first structure of benzene and this is second structure of benzene.
सर्कल लगाओ या बॉन्ड दिखाओ, दोनों चीजें दोबारा।
This is the first structure of benzene and second structure. This is second structure. इनकी जगह पर हम बेंजीन का हाइब्रिड स्ट्रक्चर भी यूज करते हैं। दिस इज हाइब्रिड स्ट्रक्चर ऑफ बेंजीन। बेंजीन बेंजीन साइक्लिक कंपाउंड है। पहले कई इयर्स पहले सोचा गया था कि बेंजीन साइक्लिक कंपाउंड की जगह ओपन चेन, बेंजीन का ओपन चेन स्ट्रक्चर क्यों नहीं है, इसका क्लोज चेन स्ट्रक्चर क्यों है। इसका ओपन स्टेट अगर ये बेंजीन अगर अरेंज होते तो ये इजीली ब्रोमीन या किसी और कंपाउंड के साथ रिएक्ट कर जाते, बट बेंजीन है ब्रोमीन के साथ रिएक्ट नहीं करता, इसकी कोई रिएक्शन नहीं होती। इस कारण से हम बता सकते हैं कि बेंजीन का ओपन चेन स्ट्रक्चर पॉसिबल नहीं है, इसका क्लोज चेन स्ट्रक्चर है और इसके बेंजीन की sp2 हाइब्रिडाइजेशन। थैंक यू।
नेक्स्ट
My name is Harsh. Today I will discuss you about resonance. Resonance is a property that shows us the different structures of a compound, because not every compound can be represented with the same structure. So we need many structures to represent them. For example, benzene. When we use resonance, the single bonds and double bonds interchange their positions. So it looks like this. And this structure becomes like this. These are called canonical structures or resonating structures, but we can represent this structure known as resonance hybrid. Resonance hybrid. These are all hypothetical structures, not in real. Another example is and it becomes like this. And these resonance hybrid structures looks like After we get this structure, we can also determine some properties related to resonance. The first property is the intermediate bond length. Here we see that in benzene, we see that the the bond length of a double bond is 1.34 angstrom and the bond length of single atom is 1.54 angstrom. But when we get a resonating structure, resonance hybrid, the the double bond is not stationary. It revolves around every single bond. So the intermediate bond length will be 1.39 angstrom. This is the first property, and second property is charge dispersion. In this, we discussed that the negative charge on oxygen will be dispersed equally on both the oxygen atom. So the negative charge will be will dispersed equally on both atoms. This is called charge dispersion. And third one is stability. The resonance hybrid structure is the stable in is very stable among every resonance structures. Resonance effect is of two types, plus R effect and minus R effect. Plus R effect is when the group gives electrons or double bond to the structure. It looks like this. In this, we observe that
वो दिखा दो बेटा वो नेगेटिव
negative.
नेगेटिव चार्ज दोनों साइड
In this, we observe that oxygen gave the negative charge to the benzene, which is and the O is group. And considering benzene our system, this is known as plus R effect. Minus R effect is reverse of this. When the system gives double bond to the group is known as minus R effect. It looks like this. In this, oxygen has high in this oxygen has high electronegativity, so it will take bonds from benzene.
एक सिंगल बॉन्ड हो नेगेटिव चार्ज वो सिंगल बॉन्ड इधर वाला
Yes, sir.
ये आगे चले जाएंगे
Yes. Thank you.